A quick rundown of the elimination method. Step 1. Make coefficients of one variable in both equations the same. Step 2. Eliminate this variable by adding or subtracting the equations. Step 3. Solve the new equation. Step 4. Substitute the solution into one equation and solve. Step 5. Check that the values work in both of the original equations. Let's look at an example. Okay, let's call this equation 1, call this equation 2. Step 1 is make coefficients of one variable in both equations the same. So for step 1, let's choose variable k. So in equation 1, the number before k is 1 and the coefficient here is 2. So in order to make them the same, we can times equation 1 by 2. So we can multiply 1 by 2. So then equation 1 will become 2k. Negative 2j times 2 will be minus 4j equals negative 3 times 2 will become negative 6. So that's step 1 done. Let's call this equation 3 now. So this has 2 and equation 2 also has 2. Step 2 is eliminate this variable by adding or subtracting the equations. So let's rewrite the multiplied equation 1, which we are calling 3. And equation 2 is still what it looked like. And to cancel out the 2's, we need to minus them, because 2 minus 2 will give us 0. So 2 minus 2 is 0, so that just gets cancelled. Negative 4 minus 3 is negative 7j. Negative 6 minus 22 will be negative 28. Now step 3 is solve this new equation. To do that, I'm going to divide both sides by negative 7 to get rid of this negative 7. And that gives us j equals 4. Step 4 is substitute the solution into one equation and solve. So for step 4, let's sub in j equals 4 into, let's do equation 1. So that's k minus 2j equals negative 3. So that's k minus 2, j becomes 4 equals negative 3. That's k minus 8 equals negative 3. Now if we add 8 on both sides, that's k equals 5. That's step 4 done. Now step 5 is check that the values work in both of the original equations. So the first was k minus 2j equals negative 3. So k is 5 minus 2 times j is 4. That is 5 minus 8, negative 3. So that does equal negative 3. So this one is okay. So, and then the next one is 2 times k, so 2 times 5 plus 3 times j, which is 4. And that should equal 22. So this is 10 plus 12, which is 22. So that's okay as well. So that's our answers. J equals 4 and k equals 5. Let's look at another example. Okay, so we've got 3m plus 5n equals 20. 5m minus 5n equals 20. So let's call this equation 1, call this equation 2, and do step 1. So we just make coefficients of one variable in both equations the same. Well, we can see that n already has the same coefficient. So we can say choose n, already same. And same, step 2 is eliminate this variable by adding or subtracting the equations. So as we can see that this is a plus 5 and this is a minus 5. So here we need to add, because plus 5 plus minus 5, which is 5 minus 5, will give us 0. So that's 8m, this is just 0, equals 40. Now step 3 is we need to solve this new equation. I'm going to divide, so we've got 8m equals 40. So if I divide both sides by 8, that gives me m equals 5. Now let's do step 4, which is substitute solution into one equation and solve. So we can sub m equals 5 into, let's do equation 1. So that's going to be 3m plus 5n equals 20, which is 3 times 5 plus 5n equals 20. 15 plus 5n equals 20. Now if you minus 15 from both sides, that's 5n equals 5. We divide by 5 on both sides, that's n equals 1. Okay, let's do step 5, which is check that the values work in both of the original equations. So 3 times m, which is 5, plus 5 times n, which is 1, should equal 20. So 15 plus 5, 20, that's good, this does. And next is 5 times 5 minus 5 times 1 should equal 20, and yes it does, so that's okay as well.